Hi there. Welcome to a new episode of Sample Space. In this episode, we're going to talk about the Scikit-learn documentation. If you've used Scikit-learn, you've bound to have used the Scikit-learn docs as well, and it does rank among one of the most celebrated documentation pages out there. It has lots of examples, but what a lot of people don't know is that there's actually someone on payroll and in charge of maintaining the Scikit-learn docs. His name is Arturo, and he's going to be the guest for today's episode. We're going to talk about some lessons learned from maintaining the Scikit-learn documentation, but we also talk about his little recommender that he made. Yes, there is actually a recommender system on the Scikit-learn site, but it's so well done that it actually kind of feels like it's done manually, when in fact it's actually built with Scikit-learn tools. There's a bunch of interesting nuggets in this conversation, and I really hope you like it. Hey, Arturo.
Hello, how are you?
Good. So one thing we should maybe mention right off the bat is that we are in fact colleagues. So we've been talking before and we've had like a pre-talk about the conversation we are about to have, but it does help to give that context. But before we were colleagues, you were actually active on the Scikit-learn side of things, and you were doing something interesting, which is, I think you were spearheading or you were sort of in charge of the Scikit-learn docs.
I'm still in charge. It's just that nowadays I'm a bit less active because of time, but I try to remain active in GitHub.
So that's why I want to start. The reason being that people give me a lot of compliments about the fact that the Scikit-learn docs are great, but barely anyone knows that there's actually a person trying to be on top of that. So the goal of this podcast is to kind of shed some light on that. But maybe to get started, what's the story? Like, how did you actually get started working on the Scikit-learn docs full time? I'm kind of curious how that ball got rolling.
So, I have to say as a little bit of background that I'm a physicist. I did my PhD in Mexico, and then I came to France for a postdoc. And then the pandemics came, and I decided to change my life into more like machine learning. So I started studying on my own side. And then I found this job posted on the internet, this job offer, where they were looking for somebody to give maintenance to the Scikit-learn MOOC. So maybe a lot of people don't know it, but there's an official Scikit-learn MOOC that is deployed both in GitHub pages and on Fon, which is a French platform. Fon actually stands for France Université Numérique. So back in the day, they were looking for somebody with a strong physics and or mathematical background so that they could follow the MOOC, and if they were able to understand the progression, then it was good. But then the whole idea was to improve the narrative in a sense. So coming from an academics background, I actually pitched myself as somebody who has a lot of experience in both teaching, which makes my writing as pedagogical as I can, and also academic writing. Mm-hmm. Because I would say that my philosophy is that if a paper or some research is well structured, well written, it's easier for the readers to understand and then cite you and then go to the same research project. You know, there's a bunch of people that think that intelligence is about making things complicated. For me, the philosophy is the other way around. If you are able to digest information and put it in the simplest words, that's the way you actually show that you understood the things. So that's how I pitched myself. And then I was hired for helping with the MOOC for 6 months. But since the beginning, the idea was to expand the contract so that other 6 months were dedicated to fully contributed to the Scikit-learn documentation. Exactly for the same reason that I mentioned before. Yeah, I think that's mostly it.
And just for clarity, because you were at INRIA doing your postdoc, I suppose, and then like the pandemic hit, like part of me is curious. You mentioned that you were also pivoting more towards machine learning. Like, was there a reason for that, or was it just, hey, we're indoors now, I see all these cool videos of machine learning stuff, let's do that? It's sort of how that exposure happened?
More or less like that, yeah. Okay. Because I had more time to dedicate fully to learning new things. I was finishing the project of my postdoc back in the day. So I started to look for things that are more applied to real life. But also like during my PhD, actually, I started working with some L1 regression models, so lasso and stuff. So I already had like a first contact to what kind of things can be done with a machine learning
it's not
pipeline.
like it's not like people in physics don't do anything with data. Like data is a thing in physics too. Like that doesn't surprise me.
Yeah, of course.
Yeah.
It's nice because, you have, when you measure a particle, you see a peak in the signal. So you have to be able to distinguish these kind of peaks from the background. And in that case, it's good to have some regularization to be able to isolate noise on this kind of.
Yeah, okay. So in that sense, it's not like you were a stranger to scikit-learn or like some of these numeric tools around machine learning. It's more that your application domain was a little bit more towards physics initially, and then you decided that eventually you wanted to go deeper and a bit more close to the sort of numericals libraries instead of just being on the application side, I guess. Would that be a correct phrasing?
Yeah, and I would say that I fully recommend people in general to do something that they are interested in if you want to learn machine learning. So in my case, it was, I had like my personal curiosities of things that I wanted to solve. So exactly during the pandemics, I had the time to actually like structure a problem and then try to solve it using machine learning.
And was it?
So that's why
do you remember that personal? Was it a physics-based project, or was it something like in your house with solar panels or something?
No, it was like a more of Mexican politics oriented.
Right. So you've got a fun data set about Mexican politics, and then that was a great excuse to explore more machine. Okay.
No, so it was like, is that true that in the newspapers they are saying this and that? So let's verify by actually playing with the data.
That makes sense. I mean, it's definitely a good move to, like, if you want to learn something, giving yourself permission to play around with a new tool is usually like a pretty good way about it. But one thing that I think is interesting about that is that you also kind of experience what it's like to learn Scikit-learn before you actually started working on the documentation.
Exactly, yeah.
You, like, maybe the year before you actually started working on the docs, you were teaching yourself using the docs, I suppose.
Yeah, of course. And sometimes I found some stuff that I was like, oh, I would like to change this because it's too. I mean, I come from a different background of programming, which is I was using mostly Mathematica and LaTeX and these kind of languages. And if you go to forums, the communities are different.
There's a company behind, like MATLAB has a big forum, but there's a company behind it, and it's not the same as Stack Overflow, let's say. It's just
exactly
different.
So also when navigating the docs, there are things that you expect to be there, but they are not. I remember that in my interview when they hired me, one of the questions was, what would you change from the scikit-learn documentation? And my answer was that there was this example on k-means clustering, where they just throw the code, but they don't give any interpretation. It was the one that tests for different hypotheses that we implicitly assume when using k-means, but nobody, I mean, the documentation didn't say like which hypotheses are those, in which is it, I mean, what are they based?
So it was kind of an example of, here's a script, here's a plot, good luck with it. And maybe there's a comment, but you don't have the story around
comments.
What. Oh, yeah, okay, exactly. But so the context isn't, can be something that's missing. Like, why is this interesting is a different claim than look at this chart.
Yeah. Exactly. Yeah. So if you only vomit plots and code, you're missing something. And I have to mention that when scikit-learn was created, one of the things that made it successful was having very concise documentation. So you would be able to just look for something, copy and paste a snippet, and then you just have a model that could work easily. But recently, I mean, a little before I got hired, the paradigm started to change to actually more tutorial-like examples in the example gallery.
More guides,
so
right?
The idea was...
more guides, I think, right? Like text and then code, and then more text and then code, and kind of like a story, kind of like a notebook in a way.
Exactly. So as scikit-learn has grown, also its complexity has grown. And that means that sometimes there are features that are super useful and really interesting, but it's not easy or not evident how to adopt these features, these functionalities.
I can also imagine there's like two concerns on that one, because I can imagine, having a guide, especially if you're a little bit more new, it's great to have the additional context, and the story can also help the reasoning, I suppose. But having a guide also makes it harder to just copy and paste the thing and fiddle around with it, because you got to copy each individual cell in a way. Is that like a concern you've also been working with, or is it? Like, I'm kind of curious what your perspective is on that one, actually.
I mean, it's better than having just the snippets, because the snippets is too flexible in a sense. So it's like a variance bias trade-off, you see, in a sense. So the snippet is really flexible in the sense that you can fit everything in a snippet, but then what's the taste of it?
Yeah.
You don't really get the narrative on when it's pertinent to use a particular algo or a particular functionality of the algo. So recently we had like a revamp of the example that was shown in the main landing page of the Scikit-learn doc for regression, because it was an example on AdaBoost and it's no longer that pertinent.
Mm-hmm.
So we actually changed the example to showcase what can be done with second gradient boosting trees.
Mm-hmm.
So in that case, we rather show something that is real in a sense, that could be a real scenario a data scientist can find, so that they say like, okay, I'm inspired by this because it's similar to my problem, or maybe I can change this or here. So it's also something that you can custom to your own use case, but it gives you more sense of when it's reasonable to use something.
Yeah, and I can also imagine there's the concern if you want to explain something clearly, or in this case, it's the histogram boosted algorithms, they are kind of established at this point in time. It's basically a very solid starting point, and there's probably tons of exceptions, but advising people just go ahead and use that is not bad advice. But then, so you also want to make sure that all the examples that are listed are also the most useful ones. It's not just about clearly explaining something, it's also about conveying what are authoritative, good examples for practitioners, which also makes it difficult to. Does that also add to the dimension of keeping it up to date, I imagine? Like every 10 years, probably the state of the art changes, right?
Definitely, yeah. So exactly. So some algorithms need to be like put aside in the priorities of what are we maintaining.
Mm-hmm.
And that means some stuff, new stuff has to come in and we have to explain it. That's part of the maintenance. Sometimes you just have like warnings or stuff that appears just because of changes in other libraries. So it's something that you just have to be aware of all the time. So it requires continuous maintenance. But also you have this big maintenance of, okay, this is no longer pertinent. So recently we are even erasing some of the old notebooks because they are quite established. For instance, if you have like a full example to show you how to load the digits dataset, it's like, okay, this is no longer really useful.
I mean, for teaching purposes, it can still be super useful, but the digits data set does not represent the state of the art anymore. That's definitely. If you were to take a step back and like look at, because how long have you been on this Scikit-learn docs project at this point? It's been a couple of years, I think, right?
Yeah, I think it was 3 years in July.
So when you start a job like that, I can imagine you have expectations, and then after a few years, you can reflect on whether or not those expectations are met. And if you were to sort of look back now, what ended up being hard about maintaining the Scikit-learn docs? Because I can imagine part of it that makes it easy is that it's a well-established project and there's like stuff to work. Like it's not a greenfields thing where you have to really start from scratch. But I'm also wondering if that makes it easy or if that actually makes it harder. Like I'm kind of curious about your perspective on that one.
Yeah, I wouldn't say it's particularly difficult or particularly easy. I mean, as everything, it has its perks and depends on what's the goal of a particular project. It can become really hard. For instance, right now I have a couple of PRs, a couple of contributions that are blocked because of the actual API. So we have to make changes in the code before I can make the changes in the displays, before I can make the changes in the docs.
Right.
You see?
Okay, but that's an aspect of the sense of Scikit-learn is also just a huge project.
Yeah. And it can really get complex. So one of the things that we want to ensure, and that, I mean, the documentation has a really good quality, but one of the things that can be improved is the linearity of the exploration that you can give to the docs. In the sense that sometimes you can get lost because there's so much complexity, there's so much information that is sometimes easy to just run in circles and you don't get a sense of direction.
It's very easy in Scikit-learn Docklands to just do side quests. It's kind of maybe
definitely
a thing that I'm hearing here. But then, one of the challenges then, if I were to rephrase it, is you do want to kind of do it in a book style where there's chapter 1 and then there's chapter 2, and at some point you've read the whole thing. But at the same time, you also want to encourage and allow people to actually take diversions and explore different parts of the library. That balance, I guess, is what you're then concerned with.
Yeah, I would say that it would be nice to have like a sense of direction. If like imagine that we have a user base that has like really heterogeneous levels of expertise. So sometimes you have to tune the narrative to more basic users or more advanced users, and you never know which public you are addressing.
Mm.
So if you could be able to say like, okay, you can start from this if you want to achieve this other thing, that would be super useful. I don't think that's possible, but what one thing that we have done for the moment is like improving the sense of proximity between topics. So one of the projects that I did, and it's quite interesting, is I was in charge of building the example recommender system. So it's basically a recommender system based on text that nowadays shows the four more pertinent examples related to the one you are seeing at the moment. So that gives you a sense of, okay, now, for instance, I'm seeing the example about clustering of text documents. So maybe I'm interested in clustering, but also maybe I'm interested in
Text documents.
TF-IDF or
Yeah.
text processing. So you, at the end of the example, you get the recommendation of these two examples.
So maybe just for the people who are listening that are aware of the Scikit-learn docs, like where can they find these recommendations? Because it's not everywhere. I think it's on some of the guides, right? Like there's different sections on the documentation page, and we're talking about the like specific deep dives on a specific topic. If you scroll to the bottom there's a couple of these, like there's a little gallery of examples there. Like that's the thing we're talking about, right?
Exactly. So we have to mention that there are three different kinds of documentation in Scikit-learn. You have the user guide, the example gallery, and the doc strings.
Mhm.
So right now we are talking about the example gallery. So at the end of each example, you get a pertinent recommendation of similar topics. Actually, when we were building the documentation, we said, sorry, the recommender system, we thought that we wanted to have something that light enough to run easily when building the docs, but also we wanted to be as respectful of privacy, because some of the recommender systems nowadays from YouTube or whatever, they are based on the user behavior. But if you go to the Scikit-learn webpage, you don't need to accept any cookies, meaning that
There's
we
none, right? I think if I'm
exactly,
yeah.
there's none. So we want to keep it like that, in the sense that we want to recover as few data from the users as possible, so that they feel comfortable enough with navigating the docs. In that sense, the recommendations are less user based and more based on the actual content of the examples.
So you say less user based, but that makes me curious. I think they're not user based at all, or am I mistaken on that one? Because it's an
No,
item to
not at
item
all.
recommender, right?
Exactly, yeah.
Yeah, exactly. Because I think, if I could be mistaken, but I think talking to you and also some colleagues, my impression is that we barely track anything on the docs, but we do some counts, I think, or we used to. I'm not sure actually. Do we have any analytics on the page?
Yeah, we still do the counts
Right.
from the users that look into the docs. I mean, we know, for instance, that the
What's the most popular page? Just gotta ask.
exactly the most popular page is train test split, for
Right.
obvious reasons. Nobody remembers the exact order of X
Oh,
train and Y train, and
and
actually it's not that hard if you think that it's of the priorities X comma Y, but then you split inside the
yeah, it's four. So the output. It's not that often that a Python function has four outputs, and when you have four
exactly
outputs, the order actually matters, and that's kind of the.
exactly.
Yeah, that is interesting. Out of curiosity, like any other pages that are pretty popular, it's easy to remember the most popular one. If you don't know, that's also just fine. But I'm just asking out of curiosity.
Definitely random forest, and we want to change that because histogram gradient boosting are also quite pertinent nowadays. So we would like them to have like a similar visibility, and nowadays random forests are way more
So,
visible.
oh, that's an interesting one, actually. So I think, if I recall correctly, on the API docs for the random forest, I think we do link to the histogram boosted variant of it. Like we've got a regressor for random forest and a classifier, and I think on the docs string itself, we now just say, "Hey, by the way, if you're using this method, please check out this other thing." And am I mistaken?
Yep.
Yeah,
Yeah. Yeah.
that's
Yeah.
something we do. But the interesting thing here is, of course, that if you look at all the O'Reilly books and old blog posts, like there's a big chunk of internet that will have the old habits in there, which probably includes this random forest estimator. Is that also a
Definitely.
thing that makes it like tricky and hard? I can imagine you are also sort of playing catch up with the rest of the internet in a way.
I mean, at some point, probably the internet is going to catch up with
right, yeah, so you're right. I should say
common
the other way around.
practices.
Yeah. No, but
Yeah.
it is an interesting aspect of the Scikit-learn docs, though. Like, part of the responsibility of a project that's just so darn popular is it's not just about explaining how the library works. It's also about explaining what are actually good practices in machine learning. And that sort of goes beyond the API at some point, which I think is also just kind of the challenge of this documentation page, I would say. I don't know if you've got any perspectives on this topic, but...
And that's why we have these three different sections. The user guide is mostly about the mathematical aspects, for instance, and the technicalities of the conversions of the loss function or this kind of things. So if somebody wants to go deeper into the details of how an algorithm works and why and when to use it, then maybe it's better to go to the user guide. But then if you want like more of the practical aspects, then the ideal thing is to go to the example gallery.
Mm-hmm.
And then the doc strings are where actually functions are shown. So they give you all the technicalities of the input and the output and which hyperparameters they accept. And there you can actually find the snippets that you can copy and paste elsewhere to have something ready to deploy, in a sense.
So one thing I'm kind of curious about, going back to the recommender bit, because there's a couple of aspects to that are sort of fascinating to me. So I've built recommenders before for clients, and it does feel like, okay, we have a righteous attitude of we're not going to do any tracking, but then how do you know that the recommender is doing a good job? Like, did you have any sort of principled way to sort of go about that? Because I asked around, and one thing that I thought was pretty funny, like when I told people, like, yeah, I'm going to interview the guy who made the recommender for the Scikit-learn docs, the first response from most people was, "Oh, that's not done by hand." Like that, a lot of people think that, at least from talking to them, the impression that a lot of people that I talk to have is that that's actually done by hand, which I think is the biggest compliment you can ever get in recommender land. But
because it's well curated by...
Yeah, that's the thing. It feels curated, even though it's automated, and that is interesting. But then I'm also kind of wondering, like, what sort of success metric did you use in order to say, is this good or not? Did you use any metric at all, or was it eyeballing, or like, how did you go about that bit?
Definitely eyeballing.
Okay, so that's okay.
But I can say that nobody has complained about the recommendation, so that's the way we can tell a posteriori that it works.
Right. Okay, no, so
but
yeah,
I do have to say that when building the recommender system, there are some parameters that I added to kind of regularize it, in the sense that you have like a minimum docs and max docs that are these parameters, min documents and max documents.
So let's take a step back and maybe also talk about how this works, because I think you're talking about a setting of an estimator, because inside of Scikit-learn, I think you've used the TF-IDF vectorizer, if I recall correctly. Is that the one you used?
Yes. I mean, yes and no, in the sense that at the end of the day, I implemented by hand a TF-IDF, but we didn't want to impose Scikit-learn to the Sphinx Gallery people, because it's also like a heavy dependency.
Mm-hmm.
So what I did was actually just use NumPy to make the things that are pertinent of this whole pipeline for the recommender system. So I had to really write everything from scratch using NumPy. And in that sense, I was able to add some liberty to choose different parameters to avoid, let's say, the overfitting in a sense.
Right. But the base algorithm is still, hey, here's a document, there's words in it. We're just going to count how often words appear. And if and then the TF-IDF trade-off is this thing where, okay, if this word happens super often, but only in this specific setting, then that's information. If it happens all over the place and not in specific categories, might be more of a stop word. And there's this reweighing factor. That's the basis of this whole recommender in the end, I think. And then a similarity.
Yeah, exactly. It's based on similarity. So the thing is that I can tell you as a funny use case. We have this example that uses to show exactly like clustering between text documents, and then you can hover and you have something that is more funny to use, more fun to use. But then you have another example that was about benchmarking random forest versus histogram gradient boosting that also used Plotly. So in the whole documentation, in the whole example gallery, you only have two examples that use Plotly.
Right.
So in the TF-IDF space, they ended up really
close to each other because they had this rare word. Yeah.
Exactly. So what we did is use this regularization so that they actually split apart, because it's not only Plotly, it's all the Plotly related jargon that appeared in the example. So it was a bit complicated to distinguish them. At the end, they still were close to each other, but because in an abstract sense of things, benchmarking the different algorithms in both cases is quite similar.
Yeah, but so
that's why we made the choice of using Plotly.
Yeah, so you still exactly. So you're fine with them being close together. You just don't want that to be because of one word. That's kind of the consideration.
Or only Plotly jargon.
Yeah, exactly. So it needs to be exactly. So, but the similarity measure is just Euclidean distance, or is it like cosine or something like that?
It's cosine similarity.
Just cosine, right? Okay. Oh, interesting. What I like about this story is that Scikit-learn does try to emphasize simple models when it's possible. Like you don't always have to go for the big ensemble. And it's kind of a nice meta observation. That's also kind of what led to the recommender that no one is complaining about. They're just nice and statically built. It's user to user, no privacy things needed. So that's actually kind of an interesting story there right away.
Yeah, sometimes we like to pitch Scikit-learn as the good old reliable set of algorithms. You can build something that is quite robust by doing simple pipelines.
Yeah, so it's boring technology, but boring in a good way. Like it just works. It
Definitely.
Yeah.
It works well.
Yeah, well, and it's all over the place. So one thing I'm just kind of curious about, because I do a fair bit of content, and I do a fair bit of educational stuff as well. It's sort of part of what I do. But you've been at this for 3 years, and some people might wonder, machine learning is great, but doing documentation for 3 years, that can get boring. But you seem pretty happy and still at it. So what about that work that you do makes it interesting for you?
I love writing.
Okay, that helps.
I actually do it on my free time. I'm more like a creative writer on my free time, but more academic writer in my normal day life. So that's one of the things. And I also love learning. When you are doing documentation, you learn a lot. It's quite similar to research in a way. So you have to read a bunch of papers, digest them, and then, as I was saying before, you have to be able to translate it to simple words. So that's what I like, because actually, I can tell you something funny. I decided to study physics because I have very bad memory. So something that I like about hard science is that you don't need to memorize things. You can deduce them. So whenever I had to do my own notes, I was always really aware of what if I'm talking to myself from the future and I don't remember anything of this. I want to be as clear as possible to myself in the future. So that's something that I still do during the documentation.
So is part of the mental exercise for you that you try to make sure that like past you can also learn from it? Is that part of it? Or is it I can also imagine it's so that future you is trying to remember it as well. Like you want to write it down in such a way that a year from now, if you look at the same page, it still makes sense.
Yeah, definitely.
Yeah.
So every single word has to be chosen specifically for clarity, for context, and for recalling the whole machinery of thinking to arrive to a given conclusion.
I'm just going to ask a different question because it just pops up. So English is not your native language, right? But the Scikit-learn docs are written in English. Do you find that challenging, or does it actually work out quite well?
I would say that I'm comfortable enough with English, mostly written English, because you can tell that spoken English is a bit more.
Your vocabulary is fine. You do have an accent, but I wouldn't worry. No, because one thing I wonder, and it's just out of curiosity, you as a non-English native, maybe it is great that you are concerning yourself with the docs, because I can imagine that you're also a little bit more aware of what English can be like to a non-native. And maybe that forces you to actually be very clear in the writing. I'm not sure if this is like I'm not a linguist, so I don't know if this is like a known phenomenon or something like that. But for example, I'm dyslexic, so that's why I read my sentences like 4 times before I actually hit enter and send it somewhere. And a lot of people have given me compliments about clear writing, but I just think that's a habit I've had to teach myself because I'm just super duper dyslexic. And part of me is wondering, like, the fact that English is perhaps not your native language, then you are aware of the fact that, hey, this English stuff that's written needs to be super duper clear. Is that like an
Yeah.
awareness? Like, right.
It's definitely important to avoid terms that are not common to somebody who is not a native speaker.
Because do we have any statistics about that, actually? I'm just kind of curious because I would imagine like the US will light up if we do stuff with the Scikit-learn docs. But part of me is thinking that like the whole world reads it at this point, right?
If you're asking about the countries that visit the most the documentation, I would say that it's the top 5. I think it's the US, India, I think Russia, China, and possibly a bit lower in the list, there's Germany and France.
Sure.
But,
I mean, it's basically the countries that have a big population in a way. So
yeah.
what I'm hearing. So it feels safe. That's kind of the entire world. Cool.
But yeah, the USA, it's definitely in the top 3, if I remember correctly.
Yeah. Okay, that also makes sense. So there's another funny kind of anecdote. I'm kind of curious what your perspective on this was. I remember when we met, and that you told me this was like the first day that I met you, and you told me like, "Oh yeah, I'm actually hired to work on the Scikit-learn docs," and I was not aware that someone was on payroll to actually work on that semi full time. And I was kind of surprised and amazed. And like, I remember the first thing that I told you was something along the lines of, "Oh, that kind of must be great because Scikit-learn, whenever I talk to people about the docs, they just rave and they're so happy and so amazed by it." And your first response was, "Yeah, that's great, but oh my God, there's so much more stuff that it could be. It could be so much better." And I just always thought that was such an interesting contrast. Like, on one hand, we've got this audience that can't help but rave about the doc quality. And on the other side, the person who's sort of in charge maintaining it can't help but notice all the gaps and like all the things that could be better. So with that introduction in there, what do you think will be like the coolest things we can add to the documentation? Because there's stuff on your roadmap, I happen to know.
Okay, so first of all, let me say that if the Scikit-learn docs were perfect, I wouldn't have a job. So for me, it's important to focus on the negative things.
Right.
So that's already a bias. But no, I do agree that they are really well done. They are community driven. So that means that we have a bunch of peer reviews that have increased the quality over time. So it's something that is really good and well thought. The only thing that I can complain the most is that exactly the only perk of being a community driven project is that we have a really heterogeneous way of doing things. There's no sense of cohesion in the narratives, in the sense that, as I was saying, different people come from different backgrounds, so they sometimes use different terms, and sometimes they speak to a public that has the same level of expertise as them. So I would like to have like a more global symphony of things where you can actually have a sense of coherence. And that's one of the things that that's in my abstract roadmap.
And like, just to give an example, I guess like something along the lines of the jargon in industry and the jargon in academia that's different, and that's a concern in this theme, like that kind of stuff.
Yeah, definitely.
Okay.
But as I was saying, not only the jargon, that's important, but I think we have more or less decided which kind of words we want to adopt, sometimes with different terms that can be used in different communities. But yeah, I would say that sometimes it's mostly about the different writing styles, which is perfect because it's community driven and that makes it diverse.
Mm-hmm.
But then I would like to have something that, follows a narrative. Let's take the example of the user guide. You sometimes get like a page that has grown like non-linearly, meaning that there's some people that come, make a contribution, and there's like a paragraph that pops up, and then maybe it didn't follow the coherence of the whole narrative of the user guide. So it's not only that it's not in the right section. So the problem is that if you're looking for a given piece of information, you don't actually know where to look at because it's really scattered all along the place. So for me, it's important to sometimes take the effort to make a huge PR to refactor everything to have a more progressive narrative.
Yeah, I can imagine. And it's not just so. At some point, it's not just the fact that, oh, like the jargon is different or the notation for the math equation is slightly different. It's sometimes also this thing of, oh, this doc can balloon if we're not careful. And you also want docs to be somewhat concise and not be like 20 pages. And then, oh, you got to cut somewhere and then wonder, this paragraph, should it be this part of the docs or someplace else? And yeah, I can definitely imagine that like all of those considerations just take a lot of time. And there's a bit of a challenge there, especially if you want to be welcoming to like outside contributions. That makes sense.
And by the way, one of the other projects that I did during these 3 years was the implementation of drop downs, which is our solution that we found to have more concise information displayed at the same time. So it had some perks in the sense that you were hiding information, but you had to make the choice of which kind of information is not that useful for the 99.9 of the users. So mathematical details, for instance,
like math proofs and that sort of thing.
Exactly.
Yeah.
So that's the kind of things that, okay, if you want to actually read it, you have to click on it. But else you have like a more intuitive narrative of how things work.
That makes sense. And I interrupted you when you were talking about things you wanted to do to the doc. So we've got this larger concern about coherence and structure. Any other things on your roadmap then?
Visualization. I would say that most of a big part of the understanding of things is by eye. So sometimes we are really used to interpret things mathematically, which is perfectly okay. But sometimes having more plots and more ways to visualize things, it really helps to get an intuition. Let's give a small detail, a small example. We have the decision boundary display. So one thing that we realize is that if you use a divergent color map, mapping the 0 of the color map, meaning the white 0.5 in the predict proba from the boundary display, then you get an intuition of the certainty of the estimator when it's making its predictions.
Yeah, you also see that there's a linear regression line sort of, and then it's like a very smooth curve. And then if you use a tree model, then you've got these hard cutoffs, and that's like that visual you kind of mean, right? Like hey, how do probabilities map into this 2D space, and that gives you some hint on how the algorithm works, like that display.
Yeah, exactly that kind of display when you can see the decision boundary of the different models. And that's really useful also when you are like looking for interactions. Maybe you don't get the only perk is that's only for two-dimensional datasets, which is not really realistic. But when you are learning, it really makes the difference to see images of what you are doing. So it makes you more confident of what creating interactions means.
Right.
For instance.
No, and like, I mean, internally we've talked about this before. Like there's some stuff on the horizon. We've got this thing called Pyodide that kind of seems to be working in the browser these days. And the dream, of course, is that at some point things become so stable that maybe we don't just have static visuals. Maybe we can do interactive things as well. Like a while ago, I made this thing that allows you to draw a data set inside of a Jupyter notebook, and it'd be great to have stuff like that on the docs, but there's so many considerations that I wasn't aware of talking to you about running that kind of thing, because yeah, you need to load up the entire Scikit-learn suite in the browser, which can be a huge payload. And yeah, like it's still a technological limit there, I suppose, but it will be really cool if we can make the docs more interactive, also to make it easier to learn like the intuition behind some algorithms.
Definitely. So what we have nowadays is a Jupyter Lite, so you can actually go and click and run the example without any need for an extra installation. So that's already deployed. It works good enough. I mean, nobody has complained once again. So at least on this side, we think that things are working well.
Yeah.
But yeah, definitely we would like to have something where you can actually click and drag and move, be more interactive to get a taste of what happens if I use this scalar instead of this other one, for instance. We have one example where I can imagine this use case, which is outlier detection. So it's quite sensitive when you are using neighbors-based outlier detection. It's quite sensitive to scaling, of course. So you can click and see how things change with respect to your scaling.
Yeah, and you can come up with fun games too. Like, hey, this classifier works pretty well. Change 3 points to see if you can make the algorithm ruin itself. Like things like that
Of
will be
course.
super fun to make. But I think the way it works right now is if you want to open something up in like Jupyter Lite, you are forced to open up a new tab in your browser right now, I believe is the case, right? Like that. It's not like we've got something that can load internally on the site itself at the moment.
Yeah, exactly. So we are using Sphinx
Hmm.
as for building the documentations. Sphinx Gallery in particular for the example gallery, and it doesn't support by the moment having any kind of this images, interactive images. Even Plotly was a bit painful to use,
Yeah,
but
the thing is also at some point to maintain this stuff, you need to know a little bit about JavaScript as well because it's more interactive. And like before you know it, just the docs itself can be a pretty big stack to maintain, kind of like a full web app, but it's just docs.
yeah, and also because we don't want to display too much code to people in the
Mm,
sense that imagine you have like the whole ipy widgets stuff that not necessarily every user will understand, and you just want to click on the pertinent stuff, but then you see a bunch of code that it's related to the interactive plot that not actually the main core of scikit-learn.
yeah, yeah, yeah. So looking back at the last couple of years, this is kind of a question I always kind of ask people. Is there anything you did not expect to learn while working on the Scikit-learn docs, but that you did end up learning? Because again, I can imagine you go into this and you have expectations, but if you look back after a few years, you might reflect and say, hey, yeah, I learned something that I didn't expect to learn while working on this.
That's a pretty good question. I would say that every day I learn something new,
Hmm.
so everything's unexpected in a sense. But yeah, I would say that I have learned stuff from other kind of fields. For instance, I created a feature which is implemented the class likelihood ratio.
Hmm.
It's something that is used in medicine for populations that have a low prevalence. Imagine that you have a disease that only one person in 10,000 persons has.
Hmm.
So you have to be able to extract some information on your, so, or I mean, you have to evaluate your model so that you are certain that it can generalize to different populations with more or less prevalence. Like instead of having just 1/10,000, you have 1/100. So this has allowed me to learn a lot about medicine or epidemiology, I'm not sure, but something that was quite unexpected. And I was even invited to some conferences with medical doctors.
That is
That was
interesting,
cool.
yeah. And I can also imagine just because Scikit-learn has so many applications, that kind of finds its way into some of the examples as well. And that is also a nice forcing function that you also don't just go knee deep on the numerics of Scikit-learn, but also see other fields that use Scikit-learn in their applications. And yeah, medicine makes a lot of sense that they do some Scikit-learn in what they do.
Yeah, I would add that sometimes core developers are too much focused on the side of developing,
Hmm.
but we rarely have the use case of, I mean, we, re- we rarely put ourselves into the user shoes. So when building the documentation, I mean, at least the example gallery, sometimes you have to become the user, and that's how you get a notion of how you can make things easier for the end user.
Yeah. But this is a hard thing in open source in general. Very typically, the maintainers of an open source project, they're so knee deep in the project that it's hard for them to imagine what it's like to be new to the project.
Yeah,
It
yeah, yeah,
kind
yeah.
of fits this bill as well. Yeah.
Sorry, once again. That's also the reason why we built the MOOC, because we wanted to help people adopt our conventions. They
Yeah.
are not really hard to adopt. That's also one of the big successes of Scikit-learn, that it's relatively easy to, once you understand fit, transform, and score or whatever, you have 90% of the usability of the library. But we wanted to make the adoption easier. And also with the MOOC, the idea is to enforce good practices within the community.
Yeah. And the MOOC has been out for a while now, isn't it? Like it feels like it's been 2 to 3 years as well, ish.
It was already there when I arrived, so more than 3
Yeah,
years.
exactly. But I remember it being promoted during COVID. That's what I remember from when I first heard about the MOOC. But it's
Seriously? Like you have nothing to do, follow the MOOC?
well, I mean, during COVID, I had plenty to do, but I vaguely remember it coming onto my retina around that time. Let me just put it that way. Now, the MOOC is pretty interesting because it feels like it's kind of this underappreciated resource, I should say. There are so many data science influencers on YouTube that sort of regurgitate some of the Scikit-learn docs, but then you have a MOOC, which is like the official course, and that gets a fraction of all the attention, even though that is the core. Like that's the thing that always kind of surprised me about the MOOC. I always promote it whenever I can. But that's
In
all.
any case, we have a big community. So I know that we could be more known in the wild, mostly because the platform is a French platform, and maybe in the international, we are not so well, the MOOC is not so well pitched. But in any case, we have around 40 persons per day that get inscribed.
Yeah, that's true. It's certainly not the case. It gets nothing. That's definitely it definitely gets traffic. Like I'm comparing it to all of YouTube, which is also kind of like a weird thing to compare against, maybe because YouTube is ridiculously big at this point. But yeah, dear podcast listener, if you haven't seen the MOOC and you're eager to learn, check out the MOOC's great. That's definitely a thing. So on this topic of people that want to learn, right? Like I do think the interesting thing about Scikit-learn, the documentation, is that is like a very primary authoritative learning resource. Like if you're interested in learning machine learning, if there's ever a listicle on the internet, the Scikit-learn docs will be a part of it. It's just fact of life at this point. But you're also, inside of Probabl, you're also working on this new thing that we should talk about. And that's the fact that we're also looking forward to maybe doing some like official certification around Scikit-learn. Before we've said, hey, there's this official MOOC, but then maybe there should also be an official certification. I know you're like part of that effort, but I am kind of curious, like how did that ball get rolling? I don't know if there's like an anecdote you can share about that.
An anecdote. I'm not sure if I have an anecdote, but let me say that the MOOC is for free. So it already gives you a badge at the end of attesting that you completed at least, I think, 70% of the total score. So we decided to have something that will bring more value to this accomplishment, in the sense that even if finishing the MOOC is already a win and having this badge is not trivial, we wanted something to be more oriented to, let's say, the actual hiring people. So the actual industry that is looking for data scientists that are able to do stuff and to understand what they are doing. So one of the things that we do is promoting not only the library, which tends to be the case for most of the certifications in the wild. Like I'm going to certify you to use my tool and I will only certify my tool. But in this case, we also want to make sure that somebody that has earned this certification is able to have critical thinking, a good understanding of statistics, and good practices. So it's not only like using scikit-learn, but actually understanding the core of the good practices. So we are trying to build something with quality here, and that is a bit based on the MOOC. So somebody that followed it already has a good percentage of,
They will already
a
have
good
done a lot of the
probability
homework
of.
for the certification, you could say.
Exactly. So we are planning to divide the certification in 3 levels: beginner, intermediate, and expert. So the MOOC would cover beginner and intermediate. The expert one is more like for a senior data scientist that already know how to debug the pipeline of another person, or actually even possibly contribute to the library. Somebody that is able to navigate the code base and find their own answers and this kind of.
What's interesting about working on a certification program from the perspective of someone who's been working on the Scikit-learn docs is that a certification program is actually not trivial. If you want to get certified easily, you just go to this website called Udemy and you will find no shortage of people who regurgitate the Scikit-learn docs into something of a course and you can get some sort of certification there. But what I can imagine is that in this case, we also want the certification to be worth something. And that's, I think, from a design perspective, super duper hard and tricky to get right. Like I know I'm aware of the fact that you're working on this effort. Now that there's this certification involved, like what would you say has become more challenging?
So if we want to have value, then you have to avoid cheating, which is likely to happen if
If the certificate has value, the people might be encouraged to cheat. Yeah, I can imagine.
exactly.
Yeah.
So avoiding cheating is not trivial in the sense that you have to find another platform that will help people pass the exam. There's this concept of proctoring that I was not even aware of before, which is like actually somebody just looking that you don't cheat, either physically in a test center or via webcam and microphone. So we wanted to do both options because we care for privacy, and sometimes people don't want to download things in their computer, even it's fully GDPR compliant. We wanted to be sure that people that don't want to show their webcam can be able to pass the exam. So we have this hybrid testing option.
So to put it simply, when you're trying to make a certification thing worth something, as in we put a stamp of approval on a thing, it demonstrates that you have some skills and people are sort of allowed to brag about it because you have to sweat a bit in order to get yourself passed. That immediately adds a concern of cheating, and therefore you have to sort of the logistics around it also become part of the challenge. Then I guess not so much just the teaching material, but in order to take it serious, the problem space just kind of grows because of that.
Exactly.
Yeah, I can imagine. Okay, cool. For people that are listening, if you're curious about the certification program, there's a link for our Discord. You can ask us anything about that. But yeah, we're also sort of getting close to time. So Arturo, thanks for coming on. This was definitely cool. I guess, is there anything you would like to tell people, maybe also with regards to people that might be interested in a career on documentation or like people who are interested in like a good tip? Like if you want to get better at docs, like what's the best habit? What's the best advice that you would have?
Already being interested in writing the docs is quite a thing. I've heard so many times that people don't like writing docs. It's not as interesting as writing code and making things work. But I would say that my recommendation is the same as for writing an academic paper. If nobody understands what you are doing, then it's not useful for the community.
Okay, that prompts me to ask a final question, actually. So, at a previous company, at some point I advocated for something, and then someone replied to me, like, oh, Vincent, what you're suggesting here is docs driven development. So, what I would sometimes do is I would first write the documentation, then hand it off to my manager, and then the manager would say, oh, yeah, this API looks good, now implement it. And I just found that act saves so much kerfuffle later. Like if we can all agree on the basic design that's well written and we agree that this is the thing we eventually want to have, like that docs first driven development aspect of it. Oh boy, did that like when people saw the value in that aspect, suddenly everyone wanted to write docs. But maybe that's also the issue in sort of in the field. Like people are not taught to write the docs first. Maybe that's also like an interesting lesson here in a way.
And for me, it's part of the design. Yeah.
Yeah.
You have to think things through before coding if you are forced to do the docs.
Yeah, that makes sense. I mean, it depends a bit on the project because in the case of Scikit-learn, first we need to have a machine learning method that has been proven on a bunch of data sets and a bunch of use cases before we can go into the project. And it's kind of hard to write the docs that say, yeah, this method will be great. That's also not the way.
But still, you can write the docs in the sense that you can decide on the API before actually building the feature. In my case, when I contributed this class likelihood ratios, one of the things that I was asked was to provide the docs at the same time as the code.
Yeah, it makes sense.
So that's part of the philosophy for accepting something new.
And it's also nice to be early in the discussion of naming conventions as well, because it's one thing to have a method name in the code base, and it's something else to have the method on a docs page. And you kind of go, well, now that I see it on the docs page, I'm wondering if the method name should maybe be improved. Like something about it being on the docs also makes you aware that other people will read it. It's also an experience like that.
Yeah. You put yourself more in the shoes of the user.
Yeah, definitely. Then this is a great place to wrap it up. Then Arturo, thanks for being on. This is interesting stuff. People can find you on our Discord, and I think you're also still active on GitHub, so people can ask you questions about the docs there. Thanks for being on, and yeah, since we're colleagues, see you on Slack.
Thank you, and see you on Slack.
Have a good one. Thanks for listening to this episode of Sample Space, and thanks in particular for making it all the way till the end. I really hope you're enjoying these podcasts that we're making here over at Probabl. If you're interested to see more, you can find the podcasts on your favorite podcast player, but you can also go to our YouTube channel. And if you're interested, you can also reach out to us on socials. You can find us on LinkedIn, but we also are getting more active on Blue Sky these days. And in particular, if you want to speak to me personally about maybe some guests I got to interview, you can also find me, as well as many of my colleagues, on our Discord. Go to discord.probabl.ai. You'll find us there, and feel free to give us any feedback you might have. I hope you enjoyed this episode, and see you again next time.